Alright, here I'm going to introduce how to graph some trig functions. So I'm going to start off with some simple ones and with sine and cosine, and when I refer to the original functions, that's what I'll be referring to. So ones with amplitude of 1, no vertical or horizontal shifts, and a period of 2 pi. So just to run through how to graph the original sine graph, it starts at 0. And then this is just a sketch, so it goes between 1 and -1, and at pi over 2, the value of sine is 1. So we go up here. The value of sine at pi is 0. The value of sine at 3 pi over 2 is -1, and the value of sine at 2 pi is back to 0. So your graph ends up looking something like this. And remember, these are actually literally sections of the unit circle. That's why they look all like parts of circles. Cosine is very similar to sine in that it's between -1 and 1, except it's actually just shifted. So if we look at what happens at 0, x equals 0, when you plug that in here, you get 1. So the graph starts at 1. And I drew these a little bit differently, so it'll look like there's different heights, but it does go between -1 and 1. You want to make sure you label your graphs. So then it goes down to pi over 2. So the value of cosine at pi over 2 is 0. Then it goes down to -1 at pi, back to 0 at 3 pi over 2, and back up to 1 at 2 pi. Again, connecting these dots, you don't want to just draw a straight line, because that would look like absolute value if I just drew straight lines. So it's very curved. It should look like something like this. And it's just a sketch, so it doesn't have to look perfect. Okay, so the reason I did this is just so I could refer to what the normal period here is. So the normal period, for it to complete one cycle, it takes the distance here, 2 pi, to complete one whole cycle of this. The amplitude is the distance from the midline, the middle of it, to the top. And I will show you what that looks like with a more complicated one. So if I look at a more complicated function like this, y equals, let's say, 3 times sine of 0.5 times x, close parentheses, plus 2. Alright, and I want to graph that. So if the question just says graph, in order to do that, we start off with the hidden skill is just drawing that little y-axis and x-axis. So let's just draw a little y-axis here. And I guess I'll go down one more. And then I want to draw my x-axis. And actually, before I do that, I'm going to kind of look at this just briefly. We went over this, but the amplitude in this one is going to be 3, and I can tell that by looking at this 3 out front. It's also going to be shifted up too, so that means I need a little bit more room above the x-axis. So when I draw this, I'm actually going to draw the x-axis to be right about, I guess I'll do it right here. Alright, so this is still my x-axis, this is still my y-axis, nothing's changed there, and let's start investigating. So the first thing I do when I look at these, when it's really complicated like this, is I start to get an idea of where my graph kind of lives. So this plus 2 right here, that means that the whole graph is shifted straight up. It's a vertical shift 2 units. So if this is x-axis, that means here's 1, 2, and then we'll actually need these up here. So this is 1, 2, there's 3, 4, and 5. Okay, so if it's shifted up 2, that means that the middle of the graph, not necessarily the top or the bottom of the graph, but the middle of the graph has gone from being at 0 to up at 2. So if I just draw a real light dotted line here, just to get an idea of where the middle is, it'll kind of help me later on. The other thing I want to do is kind of figure out the boundaries. So since I know the middle, I want to know, well, how high up does it go and how low does it go? And I want to look back at the front at this 3, and I said the amplitude is 3, So that's going to be the distance from the middle of the graph all the way to the top. So it's going to be 3 higher than the middle and 3 lower. So now that we know the middle, I can go 3 more, so that's 1, 2, 3 up, and this is going to be the top of the graph. So again, I'm going to put a little dotted line here to show that that's kind of where the boundary is up top. So that's the top, this is the middle, and then let's figure out what the bottom is. If it was 3 up, it's going to be 3 down too. So 1, 2, here's -1, and here's the bottom of the graph. There's the bottom. Okay. We have an idea now of where our graph kind of lives. We just need to figure out, and we are used to having it be a curve, kind of like sine and cosine up top, but we want it to be, well, we need to look at the other clues. So the other clue we dealt with the 3, we dealt with the 2. We need to figure out kind of where the graph starts. So like at x equals 0, is it going to be a value we can plot that's very easy, or is it not? You have to look for whether it's shifted left or right. Here we've got this 0.5x. And what that is that's actually a period change. So in the original equations, and that's what I was talking about up here, these originals, it took a distance of 2 pi to complete one cycle. This 0.5x means that it's going to be changing that period. And what it is actually, instead of it being half as long, it's actually twice as long. And the way that you could kind of think about that is, if you thought of 0.5 as a fraction, like 1/2, it's actually the exact opposite of that. It's actually 2, or 2 over 1, and it's twice as long as the normal period. So 2 times 2 pi, that's going to be 4 pi. So that's how long my period is going to take. What that means is how long is it going to take for it to complete an entire cycle. So if it's going to take 4 pi, that's going to mean that instead of making my scale here by pi over 2 like I did in my originals, I don't want to do that because that's going to be more than I need. So I'm going to count by, I want to do 4 little tick marks. I'm going to just do by pi. I'm going to count by pi on the x-axis. So I'm going to do, let's see, like pi, and then I'm going to do 2 pi, and I'll do 3 pi, and 4 pi. This you might even have to come back to later, because sometimes you'll figure out the period, but then there will also be like a horizontal shift. So you might need like one further, or you might want to have something that starts back here, depending on whether or not there is a plus or minus at the end of this x here within the parentheses. There isn't in this case, so the only thing that has changed is the graph is stretched out, and it's taller, and it's shifted up. So we can think of this sine graph as just like we would the normal one, except those things have changed. So at x equals 0, sine normally starts in the middle of the graph. In the original one, it starts in the middle, right? Meaning it starts at 0 here. But we shifted 0 to be up to 2. So now the middle is at 2, so it's going to start right here because we haven't shifted the graph left or right. Now, the graph at sine normally goes up. So the next point, it normally goes up to the top of the graph. In this case, the top is 5. And it takes 4 times as long to get there as it did before. Not 4 times as long. 2 times as long, I'm sorry. That's the 0.5. So it takes 2 times as long from this thing. So 2 times as long. It normally took from here to here to get to the top. 0 to there, it took pi over 2 to get to the top of the graph. Twice pi over 2 is what it's going to take now to get to the top. So twice pi over 2, that's going to be just a pi, which is what we have here. So to get up here, to get to 5, it takes pi distance, and that's our first dot. And now you kind of hopefully have some intuition. Since it went up first, it really, I mean, it's got to come back down. It's not going to go up anymore because we already put our boundary on the top. So it's going to come back down, and it comes back down and it stops in the middle. And again, it's going to take a distance from this dot to the next dot, a distance of 4 times as long as it did before, or 2 times, I'm sorry. So it's going to be down to 2 pi. The next one's going to be to 3 pi, and that's going to continue the path and go to the bottom of the graph, which we've already marked. So since I've already marked those, it really come in handy. Kind of once you figure out the first dot, you kind of can fill out the rest if you've created this scale correctly. 4 pi is the last one, and that's where it should end. This is just a sketch again, so now I'm going to create my curves. That's a part of a circle there. Here's the other part of the circle. If you don't know what I'm talking about when I'm referring to these being parts of circles, investigate that pasta activity that we did. The sine and cosine are just parts of a unit circle. And here we have the entire graph. We have our distance here as 3. That's our amplitude. It has stretched out. It has shifted up 2. If you have any questions, let me know. I can fix them. The only thing I'll give you one more example that I'll try to run through a little bit quicker. Y equals negative cosine, I'll just do negative cosine of x plus pi over 2, let's say, minus 1. I'll just give you another example real quick. Okay. So, let's draw our graph. We're going to graph it again. We need this. It's minus 1, so I'm going to do this. Alright. It is shifted down 1, so that means that our middle is not at 0 anymore. Our middle is at negative 1. That's where our middle is. And so then we can look at the boundaries. There's no number out front. There's a negative sign, and we'll deal with that in a second. But it would be negative 1 cosine, so that means the amplitude's still 1. So if this is the middle, that's the top. Can't really draw a dotted line because there's already a line there. And here's the bottom at negative 2. So middle, bottom. And now I need to worry about whether or not the period has changed. And there's no number multiplied times the x, right? So that means that the period is still the same as what it was before. That means it's going to be, and I'll write it above here so it's easier to see, pi over 2, pi, 3 pi over 2, and 2 pi. The period is the same as the original. Okay? So, here's my middle, and I've also got this negative sign to worry about, and I've got this plus pi over 2. The negative sign means that the graph is flipped. It is rotated around the x-axis. Y-axis, x-axis. So it's flipped around the x-axis. It's the exact opposite. So if it normally started at the top of the graph, now it's going to start at the bottom of the graph. So normally, if we're forgetting about this plus pi over 2, cosine would start at the top of the graph, meaning that, so here's the middle, it would start at the top, but it's negative, so it's going to start at the bottom. And it would normally go like this. It would go from the bottom, and it would have nowhere to go down, so it would have to go back up. And the next spot it would be over at pi over 2, right? But at pi over 2, that's a crucial point, because we can now look at this spot, right? So x plus pi over 2, that means that there's a horizontal shift to the left. So it's the opposite of this plus. It's left, pi over 2. So if we looked at what happened at pi over 2, that shifted left that distance. So basically, everything on the graph goes this way. So if I look at what happens at pi over 2 and I just move it back, I could do that if it was plus pi. I would just look at what happened at pi and then move it all the way back to the y-axis. So if my graph would go like this, that means that this point is now shifted back to the y-axis. So now I'm going to be here, and since it would have been going like this and then going up again, I know I can continue to go up. So I can continue to draw my graph. At pi over 2, it's going to be back at 0, and then it's going to be, it's got to come back down, so it's going to be here, and then all the way down and back to the middle. Alright? I can shift this, or I can draw this graph now. Doesn't look quite as smooth as before, but you get the idea. It is a complete graph. To check any of these, all you need to do is plug them into your calculator, or you can plug in different x values like pi over 2 or pi to see if they're correct. If you have any questions, let me know. Thanks.